Hey, AB Calculus, this is Mr. Ellinger, and this is the first of a set of videos going over the free response problems from Unit 8 test, because we won't really have as much time to talk about it in class, so I thought I'd record these videos. Starting with period 1, then I'll do period 5. I'll go in order that people took it. B days, it might take me a little bit to get to it because I'm stepping out of town for a couple of days in a bit. Okay, so this was period 1's test, and so they had to, they had someone swimming in a pool, and here's the velocity, and then you had to work it out from there. So if I was reading this problem as a student on a calculator section and I see any kinds of questions after this function, I'm going to put the function in right away. And I saved you time. I already have typed it in. I already checked that I'm in radian mode. I didn't see anyone who seemed like they were in degree mode, so that seemed fine. But a lot of students on this first question, when they were trying to find change direction, they set the velocity equal to 0, which actually got you a point. But then they seem to be solving that by hand, like trying to reason that through. I wouldn't dream of doing that. I would set my window from 0 to 90 because they said that the window, that the time goes from 0 to 90. And then I'd hit graph. Ooh, error syntax. What did I do? I used the minus symbol instead of the negative symbol. Classic mistake. That graph looks great. I don't need to do anything more to it. I was going to check the y's to see if the y's were any good. That seems fine. Okay, so back to the problem. Find all times t in the interval at which Stephen changes direction. And we have to give some indication of what we're doing. So we could say change direction. I'm doing this live. And that is when v of t changes sign. If you looked and you contemplated the sign of velocity, then you got a point right there. V of t changes sign. All right, so I just need that 0 right there. Some people are approximating. You could put a line at 0 and find the intersection, but I use the 0 button. That's too small of an x value. That's too big, and it's somewhere between. Oh, it's 56 on the nose. V of t changes. And you didn't have to say the sign, the way it changed it, but I'll just say, just for old habits, positive to negative at t equals 56. Boom, that was enough. You need to have the answer, and you need to show that you were considering the sign of v of t, and even writing this would probably be good enough, or writing v of t equals 0 at 56. They actually counted that as enough. They didn't ask for too much on this one. Find Stephen's acceleration at time 60. So many students were finding the derivative of this function, which is totally right. And you had to make that connection that we're trying to find a of 60, which is the derivative of velocity at 60. But I already have a derivative function up above, so I don't need to do this by hand. I can instead just go to the graph. And where do I want it? I want it at 60. Okay. Calculate the derivative at 60. Negative 0.036. Literally, that is all I need to do to show that I found it. I connected what I was given, which was velocity, to the question, which is acceleration. So I showed that connection, and you had to do that in some way to show that you were finding the derivative of the function up above. But literally, this was enough. And then it does say indicate units of measure, and that's not going to help me. And this is meters per second is velocity. So this is meters per second, so it's meters per second squared. Is Stephen speeding up or slowing down? This is not enough. We know he's moving in the negative direction, but we need to know what the acceleration is. That is the acceleration. We need to know what the velocity is. V of 60, and to find the velocity at 60, I'm just going to hit trace to put myself on the graph and say, what's the y value? It actually showed it down there. It's negative 0.159. This is not part of the answer, so it doesn't matter what I round to. I just needed to know that it was negative. So since a of 60, and v of 60 have the same sign, Stephen is speeding up. Remember, acceleration of velocity having the same sign is speeding up, opposite signs is slowing down. Okay, find the distance between his position at 20 and his position at 80. Notice this isn't distance traveled. They just want to know where he was at 20, where he was at 80, how far apart are they? Fast question, integral from 20 to 80 of v of t dt. That's a change in position. The area under a velocity curve, the accumulation from a velocity curve is the displacement, is how far you've moved. Not your distance traveled, but how far you've moved. And so literally I get out of here. I mean, I could do it on the screen, but I'm a big fan of this one. You could see I was doing some other problems earlier. 20 to 80. And I want, I only have a function in V1, in Y1. dx. Boom. 23.384. 23.384. I would go back and forth, but that number rings a bell. Officially, this is in meters, but it didn't ask for units, so you wouldn't be marked down. Had to have the bounds, do the velocity. Like, this is the setup. They just want to know, where did you get this answer? You don't have to say anything more than that. Finally, last one, find the total distance Stephen swims. And so that's the distance equals, I don't have to say that, but I'm just doing it, equals, not absolute value, but it's the integral from 0 to 90 of the absolute value of v of t. Now, a bunch of people asked me during the test, they said, where's the absolute value button? And I said, you're gonna have to find it or figure something out. Because going back to the graph, I could figure this out. I can figure this out because it's like, oh, okay, I need to count all of this positively, and I know it goes to 56, and I need to count all of this positively too. So even if I didn't know where the absolute value button was, I could just do math 9, the integral from 0 to 56 of y1 dx. Okay, and that was the positive distance. And then do the same thing. I'll just bring it down here and change it to 56 to 90. Okay, but I've got to count this positively, so I'll do times -1 to turn it to a positive number, and then say, what's that plus that? 62.164. Got the answer, no rounding at all. 0.164. So there was a way, that's meters. There was a way to work it out by just doing the separate integrals, by integrating the positive part and the negative part separately, and then absolute valuing them and adding them up. For the record, for people who want to know now, where the absolute value button is under F2. It's the first thing in F2. Remember, F2 is like just a bunch of shorthands that are kind of handy if you forget where something is. They're all right here. Well, not all, but a bunch of things that might be helpful are listed right here. So that's that's question 1. Good to go. I'm going to get ready for question 2 because I've got to put the functions in. So hold on a second. Okay, I've done a bunch of stuff. So I've got them graphed. I need the intersection points so I can calculate the intersection. And I need the first one. I'll show you why I was on the second one. Second. There we go. I got the intersection. And I want to save these for using later. So on my page, I wrote down the coordinates already. And then I said, I'm going to save this one as A and this one as B. Please make sure you save each individual coordinate. You can't say the point is point A, because then we'd want to know, well, are you talking about the X value or the Y value? And so, so I showed the coordinates of those things. And so, to save it, I can just say, all right, clear. Sorry, I was doing the other point there. X, there's the X coordinate. I'm going to save that as A, so it'll remember it. And then what's the Y coordinate I was sitting on just a moment ago? Yeah, that's it. I'm going to save that as B, hitting store as B. And now A and B are the first point, and C and D are the second point. Okay, so now I need to integrate this. Natural log is L1, or Y1, excuse me. All right, so I need to integrate this. And again, I wrote the numbers down, but of course you could write these down, or since I've defined them, you could say from A to B, or no, but you gotta be careful, from A to C if you want. It's from this point to this point. So it's up to you how you want to do it. But you got to make sure that you don't round early. Like, these numbers here are rounded. So if I try to find the area using the numbers I wrote down right here without using the entire number, then I might have an error. I might be a little bit off. And so that's why I like to save them, because it makes it a lot easier. Okay. All right. So now I need to integrate. So I'm going to math 9, and I'm going from A to C, and it's top minus bottom. And okay, I'm having a little doubt. Yeah, natural log is on top. Okay. So quit, get back to my home page and move back in here. Here we go. And do y1 minus y2 dx. Now, the only thing is I need to make sure I've defined these things for my work. There's the answer, 1.949. So if you use like y1 and y2, you'd have to tell them which one is which. Like if they ever call things f and g and h and stuff like that, and they define them in the problem, that's great. But otherwise, like I have to write out the functions here, or I have to make sure I'm being clear about what the functions are. I can't write y1 and y2 here if I haven't told the reader which one is y1 and which one is y2. Okay, but I got the answer, and that was correct. Okay, next question. Find the volume when it's rotated about y equals -3. Okay, y equals -3 is down below this one. So this got a little tricky. All right, so I know that it's going to be... let's go back down here. I know that it's going to be the integral from... again, from A to C. It's the same numbers, and I know it's going to be pi times something squared minus something squared dx, because I'm going to be slicing. Sorry, I'm sometimes skipping the wrong place. I'm going to be slicing through this thing perpendicular to the axis of rotation, so I've got to slice it this way. Okay, so I looked at the outside radius, and when it's negative, it's kind of confusing. But so I thought about it over here. Like this distance right here is the y coordinate, and now I'm just adding 3 onto it. So the first part of it is 3 plus the y coordinate, because it's just 3 bigger because I'm rotating it. I'm increasing the radius from this distance to the whole distance, which is 3 bigger. Same thing with the inside radius. If you do it to here, it's kind of confusing because the inside radius, the y value here is negative, and so the inside radius, I get kind of confused. So that's why I thought about it not there, but I thought about it over here. It's the same formula, but it makes it a little easier because the inside radius is... because the y value is positive here. So this would be my y2. This would be my x minus 1 value, or I'm sorry, x minus 2 value. And then I'm adding 3 more onto that. So the inside radius is just 3 bigger than natural log of x minus 2. Is it natural? Oh, not natural log of just x minus 2. 3 plus, apologize. I did this right on my key, but talking and writing at the same time. I actually literally wrote it like this when I did it, and that got me the correct answer on this one. Sorry, I'm running out of time, and I want to finish this one on time. So what if you rotate it around the y-axis instead? Now you're slicing it this way from this number to this number, and so it's from negative 1 point integral from negative 1.841 to the other y value, which is 1.46. You could use B and D. Oops, that's not right. It's 1.146, 1.146. It's pi, and it's another washer problem. But what this one required you to do is to convert these to solve these for x. So solving this one for x, you get x equals y plus 2. Yes. Solving this one for x, you get x is equal to e to the y. You big E both sides, and you get the x equals e to the y. So I want you to do this outside rate. Now it's just going to the y-axis, so I don't have to worry about the -3 kind of thing. And so the outside radius is from here to here. So that's the x coordinate for this one. So that's y plus 2. So it's y plus 2 squared minus and e to the y squared dy. And you needed all those components there. All right, I don't have enough time to do any summary, but those are the answers. And please email me if you have any questions. Sorry, I'm going to have to cut it off right there because I got a 15-minute limit from this program. Cheers.